Today, the case studies. One of the major concern in our society is related to environmental issues, which has motivated research materials and development from the renewable and environmentally friendly resources. This study is aimed to compare the composite strength developed with the natural fibers and polymer fibers, the glass fibers, which has environmental from manufacturing disposal specimens were fabricated with 0% fiber, 30% curva fibers, and 30% glass fiber in epoxy mix and tested in tension. The result shows higher tensile strength value of sample containing the glass fiber. However, by relating the composite strength, better specific strength results those with glass fibers. Therefore, the point of view, the mechanical strength and the glass fiber can be replaced by curva fibers in epoxy composites. The modern composites materials, particularly those reinforced with the synthetic fibers such as a glass fiber, carbon fiber, have been used in the last century to fulfill the demand required for many technological fields, from home appliance to aerospace parts. However, the energy required to manufacturing these fibers generate a huge emission of CO2, which is a major factor responsible for the global warming. In addition, the glass fiber is not recyclable. It cannot be incinerated as waste discarded in landfills. It contributes to environmental pollutions. Generally, the glass fibers were purchased from a glass companies Brazil. This company provides the repairs on vehicles and surfboards using the glass fiber as reinforced composites material. According to manufacturing glass fibers of E-type with a density approximately 2.6 gram per meter cube. It means the diameter in the range 8 to 14 mm. The tensile properties corresponding the specific value of polypropylene composites reinforced with the glass fibers and the natural fibers. The glass fibers are density the maximum 2.25 gram per centimeter cube. The tensile strength 88.6 somethings. A canna fiber 1.4 somethings fiber density and tensile density 28.3 somethings. Jute fiber also 1.46 density, specific strength 19.2 plus or minus 0.7. These are the fibers processed and ready for usages. The histogram for length and diameter distribution of fibers. Carry out the work of tensile test specimen were fabricated for each fiber concentrations with 0% fiber, 30% groove fibers and 30% glass fiber in epoxy matrix. The specimen with 0. fiber were made in silicon matrix. In this case, those with 30% of fiber were cut in the specimen size, then long continuously inserted in the steel mold. Aligned the fibers were then embedded in epoxy resins. All the specimens were manufacturing in the room temperature. The manufacturers in the steel mold were subjected to the pressure of 20 to 2.5 ton newtons. The curing time is 24 hours. These are the examples of typical tensile ruptured specimens with 0% fiber, 30% Aurora fibers and 30% glass fibers, reinforced epoxy composites. These are the comparative tensile strengths between the specimen of 0%, 30% and 30% glass fibers. A comparison the specific strength of obtained between the samples fibers 0 and 30% rubber fibers and 30% glass fiber. The conclusion of this case study is increasing the amount of both rubber fibers and glass fibers has directly influence on the increasing the mechanical behavior of composites in epoxy matrix. The neat sample has a lower strength than composites with 30% of rubber fibers and 30% glass fiber reinforce an epoxy matrix. The results show that the epoxy composites with the glass fiber is stronger. However, when comparing the result with the strength and density ratio, it is possible to conclude that the rubber fiber epoxy composite is stronger than glass fibers composites.